And this is where the Multiceptor system is installed inside of the main entrance in front of their factory. You can see the three systems there, three tanks. First one to the right is the reservoir tank. One in the middle is the 1,500-gallon Multiceptor system. On the end is the sampling box. Very impressed with the way they installed it in front of their main entrance door there, the main parking lot. Here we are with a closer view of the tanks in front of the doors. You can see the door to the right. I'm going to get a close-up. The first tank on the right is a water reserve tank, or the holding tank, that the water stands in. It's being supplied to run through the system. It runs from that tank via submersible pumps into the 8-inch crossover pipe that's installed here between the two tanks. That crossover pipe allows water to flow into the 1,500-gallon Multiceptor system, into the primary chamber where the water passes through the primary into the secondary, and then it flows into the tank, flows through the tank, and goes on out to the sampling box, which is this round cylinders you see standing at the end of the tanks here. That's also an 8-inch pipe. The 8-inch pipe was used because that was designated by IAPMO for sampling and testing procedures. Here you see the 8-inch pipe between the Multiceptor system and the sampling box, and that's the 4-inch pressure relief vent that goes back into the riser that relieves pressure back into the tank and the Multiceptor system itself. Continue on over, you see the 8-inch pipe passing through the sampling box, continuing behind, and that's the flow line. It would be like going out to the sewer. That line then returns back and is flowing back to the reserve tank that's used to supply water to the Multiceptor system. Goes down under the scaffolding and goes back in the side of the reserve tank. The scaffolding here is going to be used as an observation tower to go up on top of for the inspectors and the different people that come by here. Itself. There's a building scaffolding. Sprayback pumps. This is the other end of the line. It comes back into the water holding tank. There's your 8-inch pipe returning back. It's all gravity flow. The only forced material is from the sumps that are inside the reserve tank here, pumped into the 8-inch line to start flowing through the Multiceptor system. And we are now looking at the discharge lines with the electric conduit coming up from the grinder pumps. And there are your grinder pumps mounted on the baffle wall floor. And the little basin we make, see the 45-degree walls and the 45-degree floor that goes sloping towards the grinders. The sanitary T is not in right now because I have to be able to get in and out of the tank. This is pump number 2, check valves with the conduit for the electrical cords coming up. And this is your overhead sprayer system. That's a little difficult to see because of lighting, but there's the clamps mounting the sprayer system to the ceiling. That's what displaces the water down over the surface grease mat and sprays continuously until the grease is saturated so we can remove solids. This is your crossover sanitary T pipe in the baffle. Notice it's 18 inches off the floor. That allows the effluent to go down your grease float to the top and your solids to separate to the bottom, and the water passes up and over the T into the second chamber. Those are your stainless steel chains that are connected to your grinder pumps. In case a pump goes down, the tanks can be pulled out, the pumps can be pulled out through the manway and replaced, repaired, or done whatever. And there's your stainless steel chains connected to the top of your tanks. They're set into an eye hook in the concrete. These are your discharge lines going out with your extra electrical cable in case you have to pull these guys out. And there's a union for busting your grinder pump lines out to replace them or repair them, whatever it takes, whatever the need be. The ultrasonic sensor mounted up inside the pipe. That comes down and pings off the static level to read the levels of your water in your line, in your tank. As I pointed out before, this is your 4-inch discharge line pressure relief system that goes back into the riser into the primary chamber if there's blockage downstream or whatever, it flows water back in the tank and it allows the liquid level to lift up, and the sensors pick it up and shuts down the ultrasonic. The ultrasonic sensors pick it up and shut down the grinder pumps until the static level has been maintained again. These are your discharge lines, 1.25 inch discharge lines that connect together, tie together. They go from 1.25 inch to 4 inch, which relieves head pressure and velocity of the water. It's continued on down and discharged into the 8-inch pipe. It continues out through the sampling box, which hasn't been cut yet. And then out through the sampling box, through the return line, back to the reserve tank. Here's your second chamber. We're looking down into the second chamber. And these are your washback pumps that are installed in the second chamber for spraying the effluent or the water back over the grease mat in the primary chamber. Again, you see the conduit that the lines are run up into. That allows the pumpers to use their tools to move grease around so it can be evacuated out of the system. Again, there you see the unions. In case a pump goes down, the pump can be pulled out and replaced without entering the tank. Again, the sanitary tees are not installed on the pipes as of yet. They'll be installed tomorrow after the tanks are filled full of water. And this junction box that you see with the wiring, and this is the housing unit the ultrasonic sensor is mounted in, allowing the sensor to be protected from ultraviolet rays and things of that nature. Normally in an in-ground installation, this would be installed in a 24-inch diameter manhole, brought to grade, and this junction box that you see with the wiring for the sensors and the control panels would be inside a junction box inside that manhole to allow it to be protected and from ground environment and water. It would be a watertight manhole with a gas-tight lid. Notice the stainless steel chains that are hooked to the spray back pumps. Those are used to remove the pumps out through the manway. The manways are also used to access pumping grease out of the system that's captured inside the tank. There's an opening there, and there's a 24-inch manhole opening there that can get access throughout the 1,500-gallon primary chamber. This is a sampling box with the window cut away. Once the water starts running, I'll get a picture of this. This is where the water discharges through, and they can take samples for pressure, head pressure, FOG capture, TSS movement. This is the 24-inch sampling box. It's mounted at the end of the system, past where the discharge line connects back into. That way they can get samples of FOG increase during a pumping event. And then it circulates out through the sampling box, on out and back into the reservoir or the reservoir tank. As you can see, the spray system's kicked on. You can see the sprayers moving throughout the tank. That's what sprays back over the grease mat, saturated, causing solids to settle out of the bottom. It's kind of clogged up in this tank here because the lid's only 24-inch diameter, where normally they would be 36-inch openings. These are the simulated duplex sewer pumps that will push 140 gallons a minute into the system, simulating sewer flow through an 8-inch line. This is the inside of the reserve tank. This is a scaffolding unit we had to build for an observation tower to go up and look at the tops of the tanks. These are the ladders we put in, handrails, scaffolding, double planks on the scaffolding floor so that everything's not bouncy and springing on people, feeling like they're going to fall. Go up the steps, up onto the tank. You can observe how the tank operates. This is the walking deck here in the scaffolding, safety rails. This was real hard to try to design because it's not a normal application.